Sri Jaindra Saraswati Vidyalaya Matriculation High Secondary School, Singanallur.
Namaste. Today we are going to discuss about Lesson 10 Communication System in Class 12 Physics. First, let us see what is communication. Communication is the process of exchanging the information by speaking, writing, or using some other medium. The word communication is derived from the Latin word communis, which means commonness. Communication is the process of transmitting information or thoughts, opinions, messages, facts, ideas, emotions, and understanding from one person or to place or thing to a person or to a place or thing. So, generally, communication means exchanging the information. What is the objective or what is the aim of communication? Why do we need to communicate with each other? That only we are going to see now. We need communication because we have to give and receive the information. We have to convey the right message to the others. And we need to motivate people to receive suggestions, to give suggestions, and to issue the orders and suggestions. We need communication. Now let us see the elements of communication. There are 7 elements of communication which includes sender, bar, encoder. Encoder is a device which converts the analog signal to the binary signal which the machine can understand. Next you have got the medium channel. Finally you have got the receiver bar decoder, which is a device which converts the binary signals into analog signal. Finally we have got the feedback and what is the context which is communicated, and finally what is the noise level produced during the communication. These are the elements of communication. Now let us see the history of communication. Actually, the communication industry is one of the largest one, and it is the oldest since the communication started through the telegraph. The telegraph was the ancient communication system which was developed in 1844. Later we had telephone during 1876, and finally the radio which was there in 1887 was the communication system in the nation. So first let us discuss how telegraph was used in the previous years. An electrical telegraph was a point-to-point text messaging system used from 1840s until the late 20th century, when it was slowly replaced by the other telecommunication systems like telephone and others. At the sending station, you have got switches which are connected a source of current to a telegraph wires. Similarly, at the receiving station, the current activated electromagnets which moved the indicators, providing either a visual or audible indication of the text was there. It was the first electrical telecommunication system, and it was most widely used of a number of early messaging systems called telegraphs that were devised to communicate either text messages more rapidly than by physical transportation. After telegraphs, we had telephone. Actually, telephone was invented in 1870s. The telephone came about because they were trying to improve the capabilities of the telegraph. After the telephone was invented, wealthy individuals and large corporations primarily used it as a means of communication between specific locations. Alexander Graham Bell is often credited with being the inventor of the telephone since he was awarded the first successful patent. However, there were many other inventors such as Elisha Gray and Antonio Meucci who also developed a talking telegraph, which is the first Bell telephone in June 1875. After that, we had the radio. Radio is the technology of signaling and communicating using radio waves. You know what is a radio wave? It is one among the waves in the electromagnetic spectrum. Radio waves are the electromagnetic waves of frequency between 30 Hz to 300 GHz. They are generated by an electronic device called a transmitter connected to an antenna which radiates the waves, and finally it is received by another antenna connected to a radio receiver. And actually radio is a very widely used in modern technology in radio communication, in radar system, in radio navigation, in remote control, remote sensing, and other applications. So, till now we have seen the introduction, the history, and what are the parts of communication. Now we are into our syllabus. Our syllabus includes modulation. So what is modulation? Why do we need this modulation? That only we are going to see now. For the transmission of the information through short distances, it doesn't require any complicated techniques. But if the energy of the information signal is sufficient enough to be sent directly, it can be done. But however, if the information in the audio frequency range 20 to 20,000 Hz, if it is need to be transmitted to a long distance across the world, certain techniques are required to transmit without any loss. So only we use our modulation techniques. So what is modulation? For long distance transmission, the low frequency baseband signal, which is the input signal which has to be transmitted. This is superimposed onto a high frequency radio signal by a process called modulation. In the modulation process, a very high frequency signal called carrier signal, this is the radio signal, is used to carry the baseband signal. As the frequency of the carrier signal is very high, it can be transmitted to long distances with less attenuation. Attenuation means power loss. The power loss will be less when the carrier signal is used because the frequency of the carrier signal is very high. So during the transmission, if there is a power loss also, the main signal, the base signal will not get affected when this process of modulation is done. Generally, the carrier signal is a sine wave signal which is shown in the animation nearby. A sinusoidal carrier wave is represented as EC is equal to EC sine 2 pi mu c t plus phi, where you know that the capital EC is the amplitude of the carrier wave, mu c is the frequency of the carrier wave, and phi is the phase of the carrier wave. These three are the major parts of a carrier wave. Next, we will see the types of modulation. Types of modulation means we know that the base signal is modified by the carrier signal. Carrier signal consists of three parts. In the previous slide only we saw the three parts are amplitude, frequency and phase. So if the amplitude, frequency and phase is changed in accordance with the baseband signal, we get the three types of modulation. So if the amplitude is changed, it is called as amplitude modulation. If the frequency is changed, it is called as frequency modulation. And if the phase is changed, it is called as the phase modulation. These are the three types of modulation in analog modulation. Here the modulator is given, the carrier wave is given. Amplitude modulation, here only the amplitude is changing. What is amplitude? Amplitude is nothing but the maximum distance or maximum displacement from mean position. So you can see in the diagram, in the animation, you can see the amplitude is maximum at some region and it is minimum at some region. Next is the frequency modulation. Frequency means number of waves or number of vibrations per second. So when the frequency is changed, it is called as frequency modulation. In the animation, you can see some regions where there are more waves. In some region, there are less waves. Hence, in some region, the frequency is high. In some region, the frequency is low. That is frequency modulated base signal. This is. Now we will see the amplitude modulation, which is generally represented as AM. As you know, per the definition, if the amplitude of the carrier signal is modified in proportion to the instantaneous amplitude of the base signal, it is called as the amplitude modulation. When amplitude is modified, the other two, phase and frequency of the carrier signal, will remain constant. This amplitude modulation is used in radio and TV broadcasting. See, the first figure represents the base signal. Second one is the carrier signal. So, See how the amplitude modulation is done. The amplitude of the base signal is superimposed on the carrier signal. So you have got certain regions of minimum amplitude and certain regions of maximum amplitude. Now let us see the advantages and limitations of amplitude modulation. First, advantages. Advantages are the transmission and the reception process in the amplitude modulation will be easy, and you need only lesser bandwidth requirements, and if you see the cost, it is low compared to the other two methods. These are the advantages of amplitude modulation. Now if you see the limitation, first point is noise level is high when compared to the other two. Noise level is high in amplitude modulation and the efficiency is also low, and the operating range is also small in amplitude modulation. So we move on to the next method, which is frequency modulation. Frequency modulation means the frequency of the carrier wave is modified in proportion to the instantaneous amplitude of the base band signal is frequency modulation. Here the amplitude and phase will remain constant, only the frequency is changing. So the amplitude and phase will remain constant. The increase in amplitude of the baseband signal increases the frequency of the carrier signal and vice versa. This leads to compressions and rarefactions in the frequency spectrum of the modulated wave. Louder signal leads to compressions and relatively weaker signals to rarefaction. So this is how frequency modulation is done. First one is the baseband signal, second one is the carrier signal. So the carrier signal is superimposed on the baseband, and you can see the frequency modulated signal where in some regions the frequency is greater, in regions like A and C, in B and D the frequency is less. So this is how the frequency modulation is done. Now the advantages and limitations of frequency modulation. Advantages: in frequency modulation there is large decrease in noise, and this leads to an increase in signal noise ratio. Then the operating range is quite large compared to the amplitude modulation. The transmission efficiency is very high as all the transmitted power is useful. And in frequency modulation, bandwidth covers the entire frequency range which the human can hear, from 20 Hz to 20,000 Hz. Due to this, the frequency modulated radio has better quality compared to the amplitude modulated radio. We have got the FM radio. No, FM radio is more better than the AM radio. The limitations of frequency modulation. Frequency modulation requires a much wider channel. FM transmitters and receivers are more complex and it is also costly. And in FM reception, less area is covered compared to the amplitude modulation. The final one is phase modulation, which is generally referred to as PM. In phase modulation, the instantaneous amplitude of the baseband signal modifies the phase in the sense the angle of the carrier signal, keeping its amplitude and frequency as constant. This modulation is used to generate frequency modulated signals also. It is similar to frequency modulation except the phase of the carrier is varied instead of varying the frequency. See, this first one is the message signal or it is the base signal. The next you have got the carrier signal. See how the phase modulated signal is done. The angle or the phase changes at some places. This is the phase modulated signal. Now the advantages and disadvantages of phase modulation. First one is phase modulation is a simple contrasted to frequency modulation, and it is used to find the velocity of a target by removing the Doppler data. This needs a constant carrier which is achievable during phase modulation, however not in frequency modulation. The main benefit of this modulation is signal modulation because it permits the computer for communicating on higher speed using a telephone system. When the information is being transmitted without intrusion, then the speed rates can be observed. And one more advantage in PM is improved immunity towards the noise. The following are the disadvantages of phase modulation. Phase modulation needs two signals by a phase varying among them. Through this, both the patterns are required like a reference as well as a signal. And this type of modulation requires hardware which obtains more complex due to its conversion technique. Phase ambiguity arrives if we exceed in index pi radian of the modulation. And the phase modulation index can be enhanced by employing frequency multiplier. These are the disadvantages of phase modulation. So far we have seen how a modulation is done and what are the types of modulation. Finally, we are going to discuss about where this modulation and demodulation is applied. That is the application of modulation techniques. It is the one which is used in our systems, which is nothing but the modem. The modem expansion is modulator come demodulator. Both is combined in this device. A modulator, demodulator or simply modem is a computer hardware device which converts data from a digital format into a format suitable for an analog such as telephone or radio. A modem transmits data by modulating one or more carrier wave signals to encode digital information, while the receiver demodulates the signal to recreate the original digital information. The goal is to produce an electrical signal that can be transmitted easily and decoded reliably. Modems can be used with almost any means of transmitting analog signals, from light emitting diodes to radio. So this is the important application of modulation what we had discussed in our data.